Assalamu alaikum wa rahmatullah. Today inshallah we're going to solve Cambridge exam October-November 2021 paper 61. Let's start it. Question 1. A student investigates the volume of dilute sulfuric acid that would react with 25 cm³ of aqueous sodium carbonate. The burette was rinsed with water, then it was rinsed with dilute sulfuric acid. Then after that the burette was filled with dilute sulfuric acid. 25 cm³ of sodium carbonate was added into the apparatus labeled A. Then few drops of methyl orange indicator added, and we place the apparatus A on a white tile, starting adding dilute sulfuric acid slowly from the burette to the sodium carbonate solution until the color of the methyl orange indicator changed from yellow to orange. A. Name the apparatus labeled A. A is a conical flask. State one safety precautions that should be taken when using dilute sulfuric acid. We should wear safety goggles or gloves. Give a reason why we place white tile. White tile makes you clearly see the color change at the end point. Describe what should be done to the apparatus labeled A as we are adding dilute sulfuric acid from the burette. Adding dilute sulfuric acid, we should swirl or stir the flask to mix the acid with the sodium carbonate. State why the burette was rinsed with water and then with dilute sulfuric acid at the start of the experiment. It was rinsed with water to remove any residue from the previous experiment. Then with dilute sulfuric acid to remove the water from the burette and prevent dilution of the acid. Question 2. Student investigate the rate of reaction between small lumps of calcium carbonate and dilute hydrochloric acid. We are doing this experiment at two different temperatures and all other conditions were kept the same. Here, the small lumps of calcium carbonate and dilute hydrochloric acid and the gas collected in a gas syringe. In the first experiment, we are using 25 cm³ of dilute hydrochloric acid, and the temperature was measured with a thermometer. 10 grams of lumps of calcium carbonate was added and the bung was replaced immediately and we use a stopwatch. The volume of the gas collected in a gas syringe was measured every 50 seconds for 250 seconds. In experiment 2, we are using the same volume of dilute hydrochloric acid and then we warm it using a Bunsen burner. The temperature of the dilute hydrochloric acid measured with a thermometer, the same mass of calcium carbonate was added to the boiling tube, and the volume of gas collected again every 50 seconds for 250 seconds. Here from the diagram we can measure the temperature of the first experiment, which is 23 degrees Celsius. And the volume of the gas collected in the first experiment every 50 seconds, as we can read the volume from the gas syringe scale: 0, 12, 20, 27, 32, and 36. Then we will go for the second experiment. Using the diagram, the temperature of the second experiment is 44 degrees Celsius, and again we will record the volume of the gas collected every 50 seconds. Here from the scale on the gas syringe, it's 0, 25, 35, 40, 40, and then finally 40. Plot the results for experiment 1 and experiment 2 on the grid. Draw a curve of best fit for each experiment and take care you should label your curves. Here is a curve for experiment 1 and the second is for experiment 2. All points should be plotted correctly, and here in experiment 2 we have a plateau region showing the constant result at 40 cm³. From your graph, deduce the volume of the gas collected in experiment 2 after 120 seconds. Show clearly on the grid how you worked out your answer. So here we will go on the x-axis, determine the point for 120 seconds. Then we will go upward to meet with the curve of experiment 2 showing 36 cm³, which is the volume of gas collected at 120 seconds. So the answer here is 30 cm³. Explain how the results show that the reaction experiment 2 has stopped. The reaction has stopped because the gas volume becomes constant. We collect the same volume, which is 40 centimeter cube, for 3 times, so the reaction has stopped. Predict the volume of the gas would be collected in experiment 1 after 800 seconds. Explain your answer. The volume of gas collected after 800 seconds is also 40 centimeter cube because we are using the same mass of calcium carbonate, the same volume and concentration of the acid as in experiment 2, so the maximum volume can be collected is 40 centimeter cube. A student stated it would be an improvement to measure the volume of gas if we collect the gas every 25 seconds. Explain why this is an improvement. This will be an improvement because we have more readings and more points, so we can plot more better curve with clear result. State 2 changes to the apparatus to improve accuracy of the results obtained in experiment if the experiment is repeated using the same thermometer. Change number 1, we should use a pipette instead of the measuring cylinder because the pipette is more accurate, so this will improve the accuracy of the result. The second change, use a divided flask. So no need to replace the bung and no gas will escape. Because the student, after adding calcium carbonate, he quickly replaced the bung, so some gas may escape at this step. To avoid this, we should use a divided flask. Describe how the method in experiment 2 could be changed so the results can be obtained using hydrochloric acid at 1 degree Celsius. So we have to do the experiment at this temperature, 1 degree. We should put the tube in an ice bath. Question 3. Solution Y and solution Z were analyzed. The following tests were done on the solution. First, test on solution Y. Solution Y was divided into 4 portions into 4 test tubes. On the first one, a strip of universal indicator paper was dipped into the first portion of solution Y, and the universal indicator paper turns blue. So here we have alkaline solution. Test 2. Aqueous copper sulfate was added to the second portion of solution Y. A blue precipitate is formed. Copper sulfate will react with the alkaline solution containing hydroxide ions to form a blue precipitate of copper hydroxide. Test 3. A flame test was done using a third portion of solution Y. A red flame was seen. A red flame indicates the presence of lithium ions. Test number 4. 2 centimeter cube of dilute sulfuric acid was added to the fourth portion of solution Y. No visible change seen, but the test tube becomes slightly warmer. Here we have lithium ions and hydroxide ions, so the solution is lithium hydroxide, and lithium hydroxide reacts with sulfuric acid in a neutralization reaction, so it's an exothermic reaction. We could feel the test tube becomes slightly warmer. Suggest a pH of the solution Y. It's alkaline solution, strong alkali, so it could be 12, 13, or 14. Identify solution Y. Solution Y is lithium hydroxide, and you should write the name in words and formula. Then test on solution Z. Solution Z was aqueous ammonium sulfide. Complete the expected observation. First, solution Z was divided into 3 portions, into 2 boiling tubes and a test tube. 5 centimeter cube dilute hydrochloric acid added to the first portion, then the mixture was warmed, and a piece of filter paper soaked with acidified potassium manganate held at the mouth of the boiling tube. Here, the hydrochloric acid will react with the ammonium sulfide. As we can see from the equation, the product will be ammonium chloride, water, and sulfur dioxide gas. Sulfur dioxide gas can be tested with acidified aqueous potassium manganate, and the color change of the acidified aqueous manganate will be changed from purple to colorless. Name the gas formed at C. It will be sulfur dioxide. 5 centimeter cube of the aqueous sodium hydroxide was added to the second portion of solution Z in a boiling test tube. The mixture was warmed and the gas given off was tested. Here, the sodium hydroxide will displace ammonia from the ammonium sulfate, so the test will be the litmus paper turns into blue color or change the color from red to blue, and the gas given off is ammonia. 1 centimeter cube of dilute hydrochloric acid followed by few drops of aqueous barium nitrate added to the third portion of solution Z. No change because we don't have sulfate ions. Question 4. Tartrazine is used as yellow food coloring. Plan an investigation to find out if a yellow sweet contains tartrazine or not. Explain how your results will tell you if the sweet contains tartrazine. You have an access to all normal laboratory materials, a yellow sweet, and a sample of tartrazine. You may draw a label diagram as part of your answer. So we will do a chromatography to compare between the yellow dye present in the sweet and the tartrazine yellow food coloring. First, we will dissolve the sweet in water to obtain the solution of the yellow color from the sweet. Then we will carry out chromatography using a suitable solvent. Okay, place the spot of the sweet solution on the base line and another spot of the tartrazine on the same line of the chromatography paper. So here we have the spot from the yellow sweet and the spot of tartrazine. Then we will use suitable solvent, so the level of the solvent should be below the baseline where the spots has been put. Then let the solvent rise near to the top of the paper. Here the solvent will reach to this point, which is the solvent front, and both dyes move with the solvent. This is the yellow spot from the sweet and this is the yellow spot formed from tartrazine. We will measure the RF value for both spots. If they have the same RF value, so the sweet contains the same food coloring, which is tartrazine. The RF value should be measured from the paper, the distance traveled or moved by the spot divided by the distance traveled by the solvent. If both spots have the same RF value, so the yellow sweet contains tartrazine. Here we come to the end of our exam. Like the video and subscribe to the channel to receive all the updates. Thank you for watching. Wish you all best of luck.